Section 4.5 goes deeper into logarithms, and we're going to talk about all the different properties of logarithms. A lot of them you should remember from Algebra 2, so this should still be a review. But some of you may not have really understood them very well back then, so don't hesitate to ask questions. You want to make sure you get them this time around. So let's start off with this. It says that as long as our base is a positive number and not equal to 1, then the following 4 things are always true about logs. The log base b of 1 always equals 0. So that means that if this number right here after the log is a 1, regardless of what the base is, that logarithm always equals 0. The second property tells us that if the log base b of b, so if you have the same number after the log as the base, that always has to equal 1. And those two should make sense to you, because if we think about it, b to the 0 equals what?
1.
And what does b to the 1 equal? B. So if you rewrite those in exponential form, if you get stuck, then you should be okay. 3 and 4 are a little less intuitive for most students, so take a look really closely at those and what they're saying. They say that we have log base b of b to the x. So the two bases are the same there. Then the bases kind of undo each other along with a logarithm, and it just equals x. That should also make sense if you think about it exponentially. To loop the log, if we say b to the x equals b to the x, that has to be true. And finally, the fourth one is really different. It says b to the log base b of x. So you have a base to a logarithmic power. They still undo each other as long as the bases are the same. So as long as the big base here at the bottom and the little base of the logarithm are the same, that will still undo each other and just equal plain x, whatever's after there. So let's go over this example. Look at part A. It says log base 3 of 1. Well, 3 to what power equals 1? 0. How about log base 4 of 4? 1. And that's something you need to kind of get used to. Those two, you should be able to look at those and just immediately know the answers to those. Anytime there's a 1 right here, the answer is going to be 0 regardless of the base. And anytime the base and the number after the log are the same, the answer is going to be 1. And this is another one you just kind of have to memorize. Log base 7 of 7 to the 3 equals what? 3. So take a look at that.
If the base and the number are the same.
Right.
Even if there's an exponent.
Yeah, I guess that's harder to say, but yeah, if the base here and the base here are the same, then they kind of undo each other. So if there's another exponent after the log and they have the same bases, then it's going to equal the exponent there.
So you could say technically it's like what the power is, because on 4 and 4 the power is next to it.
Yeah.
Right, yeah, that's really a good way to say it. So it's going to equal the power if the bases are the same. And that's the same situation we have in part D. If we have base b to the log base b power of 3, then see how the bases are the same? Then it's just going to equal the number after the log. So it's going to equal what? 3 as well, yeah. And that's because these guys kind of undo each other there and undo the logarithm as well. Okay, so now that we've done the basic properties, we're going to get into the properties that will allow you to solve logarithmic equations and really work with them. They are, we'll take these two first, the product and the quotient property. The product property says that if you have log base b of two things multiplied, m times n, then it also equals the log of those two things added together separately. So two logs added together has to equal a single log with the things after the log multiplied. That's called the product rule. I always remember that because when we multiply, what do we do with our exponents? You add them, and logarithms are just exponents. So that's how I always remember whether to add or subtract. So 2 logs added equals 1 log multiplied. For example, let's say we have log base 3 of x times y. If I want to split that up into two separate logs, that would just equal log base 3 of x plus log base 3 of y. So you could go forward or backwards. If I start you out with log base 3 of 2 plus log base 3 of 7, what does that have to equal?
Log base 3 of 14.
Log base 3 of 14, yeah. Because, you know, it doesn't matter which way you go with this. You go whichever way makes sense for the problem you're working on. So we'll actually go forward and backwards with these. Likewise, when we divide with exponents, what do we do to them?
Subtract.
We subtract. So it turns out that the log, as long as all the bases are the same, the log of two things divided is equal to two separate logs subtracted. And you just have to remember that the one that's on top is a positive and the one that's on bottom is a negative. But that should make sense because when you have variables in the denominator, their exponents are understood to be negative. So the log of two things subtracted equals one log of those two things divided. In other words, take a look at this example. Log base 4 of x over y. That can be expanded out into what?
Log base x minus
Log base 4 of x minus log base 4 of y. Good.
The bottom's understood to be
The bottom's understood to be the one that has the minus in front of it. So it's important that you not get them backwards when you're dealing with division. And you could also go the other way. Let's say I start you out with log base 4 of 25 minus log base 4 of 5. Well, because those two logs are subtracted, they can be combined into a single log
log base 4.
of those two numbers divided. So what is 25 divided by 5?
Log base 4.
Log base 4 of 5, yeah. So you can either use it to expand or you can use it to condense it down into a single log. Any questions about those two properties? Okay, well that brings us up to the power rule. The power rule says that as long as m and b are positive numbers and the base is not equal to 1, then log base b of something to the p power is equal to p times the log base b of the base that was there to start with. It sounds really weird, but once I show you, it'll make a whole lot more sense. Another way of saying that is a power after the log equals a coefficient before the log. The power after the log is the same as the coefficient before the log. So for example, for the power rule, let's say that we have the log base b of x to the 5th power. That's the same thing as 5 times the log base b of x. A power after the log can just be brought to the front and made into the coefficient before the log. Everything else will be left the same. And you can go the other way. If I tell you that 2 log base 4 of 7, that's really the same thing as log base 4 of 49. Do you know why?
Because you put the 2 on top of the 7 and you get 49.
Right, yeah, because 7 squared is 49. So if you take the coefficient and you move it back behind the log, it will become 7 squared. So there are all kinds of ways you can use this to clean up a problem, reduce it down, or expand it out, depending on what you need. And our final property here, number 8, before we start practicing these, says that if log base b of x equals log base b of y, then x has to equal y. Let's see if we believe that. Let's say we have log base b, well, let's give it an actual base. How about log base 7? Log base 7 of 4 equals log base 7 of x. Well, doesn't it make sense to you guys that if those two things are equal and everything else in there is equal, then it must be true that 4 equals x? So some people say, like, as long as you have a single log equal to a single log and the bases are the same, you can just pretend the logs aren't there. And you can solve it that way.
Even if there's a coefficient.
No, they would have to be a single log.
Okay.
So if there were a coefficient first, like if you had 2 log base 7 of 4 equals log base 7 of x, you would need to move the 2 first. So you would have to get it into a single log, and if you raise that to the second power, that would be 16 equals log base 7 of x. Then once it was 1 log equals 1 log, so the logs are the same, and the numbers are the same here, the bases, then we know that 16 would have to equal x in that case. So you guys think you're ready to do some practice problems? Okay, this is a good place for me to stop and like cut it into a separate video. That's kind of all the notes, so we'll just be practicing from here on out.